Wave speed. What does it depend on, and how do you calculate it? The speed of a wave depends on the medium through which it travels. Waves generally travel fastest in solids and slowest in gases. A great example that illustrates the difference in the wave speed in a solid versus a gas occurs during the demolition of a building. Old buildings are often demolished by filling them with explosives, and when the explosives detonate, the building collapses. Well, what happens as the building collapses, it creates a wave through the air, a sound wave, and also creates a wave in the solid ground. If you're observing from very far away, let's say from 5 miles away, the demolition of a large building, you will feel the wave in the ground prior to hearing it via the sound through the air. And that demonstrates that waves travel fastest in solids and slowest in gases. Now, wave speed can be calculated by multiplying the wavelength by the frequency. So wave speed measured in meters per second is equal to lambda, Greek letter lambda, measured in meters, multiplied by frequency, which is measured in hertz. Now here I have an illustration of a water wave passing a post which is sticking out of the water. So now during each vibration of the wave travels a distance of one wavelength, and I have that marked. Wavelength would be measured from crest to crest. So that would be one wavelength. Now, for example, a fast-moving wave travels lambda in a small amount of time. So that means that its period is short, as opposed to a slow-moving wave having a large period as it travels. So wave speed can also be calculated using the formula V is equal to lambda divided by t, and t is the period measured in seconds. Now, referring back to that diagram that I just showed you, here's an example we're going to calculate. An ocean wave has a wavelength of 20 meters. The wave passes a pole protruding from the water once every 5 seconds. So that would be the period of time for that wave. A, what is the frequency of the wave? Now, frequency means how many waves have bobbed up and down in 1 second. And B, what is the wave speed? So to begin with our solution, what I'd like you to always do is list the given information from the problem. So here we read that the wavelength is 20 meters. So we write wavelength is equal to 20 meters. And we're told that the period is 5 seconds. So t is equal to 5 seconds. T stands for period. So to answer A, what is the frequency? We use the frequency formula. F is equal to 1 divided by t. So that would be F is equal to 1 divided by 5. And 1 divided by 5 is 0.2. And the units are hertz, Hz. Or we can read this as 0.2 waves per second. Remember, frequency is the measurement of cycles per second. 1 cycle per second is 1 hertz. Now, to calculate the wave speed, V is equal to lambda times frequency. So V is equal to 20 times 0.2, or the wave speed is 4 meters per second. Now, as an alternative, if you want, you can always use the other formula. V is equal to lambda divided by the period.